So this video is about using the law of sines in the case that we're given information in the order side-side angle, okay? If you'll think back to geometry, we couldn't use side-side angle to prove triangles congruent, all right? But we can use information given in side-side angle format to solve triangles using the law of sines, and this is called the ambiguous case, okay? Now there's 7 different scenarios. We're not going to go over all 7 of those here. You can look those up and do a Google search. But I'm going to go over 3 different examples here. One where there's one triangle that can occur, one where there's no triangle that can occur, and then a third where there's 2 triangles that can occur based on the given information. Okay? So we're still dealing with oblique triangles here. Those are triangles that do not have a right angle. We're still using the law of sines. So again, you're going to choose any 2 of these ratios or any 2 of these ratios to solve for the unknown. Okay? So let's look at example problem number 1 here. So we've got a triangle that has the following measures. Angle A is 131 degrees, side A is 25 yards, and side C is 8 yards. Okay? So, how many possible triangles can have these given measurements? Well, angle A is obtuse. Okay? That means the other 2 angles have to be acute. All right? Now, side A is larger than side C. This can be the case. Now, if these values were reversed, if this said A is 8 and C is 25, then you would know there's no triangles there because angle A is the largest angle, side A has to be the largest side. So because this is true, then we're going to have one triangle here that can have these measurements. Okay? Because angle A is obtuse and because the side opposite A is greater than the other given side, then only one triangle can exist. So that's one of the 7 scenarios. Okay? All right. So we're going to use this ratio, A over sine of A equal to C over sine of C, because we've got these 3 given values. Okay? We don't know what angle C is. We know it has to be acute. All right? So we're going to use A over sine of A equals C over sine of C. Now, we're going to cross multiply. And when we cross multiply, we get this equation right here. Okay, we want to get sine C by itself, so we're going to divide both sides by 25. And now when I'm solving for an angle measure, remember back to right triangle trigonometry and inverse trig functions, we're going to take inverse sine of this ratio. Okay, and this whole ratio here has a value of about 0.241507. Now notice I took this out quite a few places after the decimal. I did that on purpose. Okay, if you only do 0.24, it's going to create more error in the angle measure you find. Okay, so the further you go out here after the decimal, the more accurate your angle measure is going to be. Okay, so using inverse sine, it's going to give us the value for angle C, and we get an angle measure of approximately 13.98 degrees. So now we have 2 angle measures. We know angle A and we know angle C, so we can find the measure of angle B just using some basic geometry here. So again, we know the 3 angles in a triangle sum to 180 degrees. Let's substitute the values we know, okay, and then we'll solve for B. So B should be approximately 35.02 degrees, okay? So now I have that value. I can go back up and use my ratios here. Again, we want to use given information as much as possible. I'm going to use this ratio because I was given both A values, and I'm going to use this. I'm going to use a calculated value, but I have to based on the way I was given the information, okay? So my equation will be B over sine of B, 35.02 degrees, equals A over sine of A. I'm going to cross multiply, okay? Cross multiply. I want to divide now by sine of 131, okay? I'm going to find out what this decimal is, and that'll be my length for side length B. So B should have a value of approximately 19.01 yards. On to problem number 2. Okay, we want to solve the triangle that has the following measures. Angle C is 100 degrees, side A is 33 kilometers, and side C is 29 kilometers. Now, you should already be able to answer this question, how many possible triangles can have the given measurements. I'm going to go ahead and go through the math and prove what that answer is, and then we'll kind of revisit the original question. Okay, so I know side C and angle C, and I know side A. So I'm going to use A over sine of A and C over sine of C as my ratios. Okay, so I want to write that equation. So A over sine of A equals C over sine of C. Okay? Cross multiplying like we have been doing. I want to divide now by 29. Okay? Now, I want to find what this whole ratio is right here. Okay? And when I multiply 33 times sine of 100 and divide by 29, I get this value, 1.120643. Now, if you couldn't tell from the original question how many triangles you should have, hopefully this is another trigger that tells you how many triangles there are going to be, okay? When you do inverse sine of this value, okay, you put that into a calculator, you're going to get an error, okay? This can't happen, all right? I'll talk about why in just a second. But when you put this value into your calculator, you're going to get an error, okay? What that means is we're going to have no triangle here, all right? So let's think about this a little deeper. The sine of any angle must be between -1 and +1, inclusive. That includes -1 and +1, okay? As an inequality, we would write it like this, okay? So the sine of A always has to be in between -1 and 1 inclusive. Well, this value is outside of this domain, okay? That's why this is an error, all right? So when you do your calculations and you get a value outside of that domain, that means no triangle can exist, all right? Now, logically, going back to the beginning of the problem, angle C is obtuse. That means angle A and angle B would have to be acute angles, okay? This is the largest angle then. So C has to be the largest side, okay? And C is not the largest side because A's given value is greater, okay? So using the logical part of your brain, we should be able to come to this conclusion before doing all this work over here. Just reading the problem, you should have been able to answer the question, okay? Any questions on number 2, let me know.